Hello everybody. This is presentation on the HP Cool AI OS for the frontline worker as shown in the diagram. I can see this is a system working on the large language model that is sitting on a device that has a capability of answering user questions. For example, the inventory lookup for customer assistant. And then what I'm trying to present today is the concept which focus on this storage over here. So when the customer asks a question, the LLM will trigger a query, and then if the question is something to do with the database, to access some inventory or question regarding for healthcare, maybe a doctor and a patient interaction, the information stored from the patient might be stored in this storage. It can be in the form of vector store, or it can be some sort of a structured database like MySQL, or probably a sophisticated knowledge graph data that can be stored with a relationship graph that is embedded in, for example, the Neo4J is one of the commercial available database that is capable of doing both vector storing plus structured database that is relationship established as a graph, knowledge graph. So this talk is about explaining to design team what is actually knowledge graph. You can see on this diagram there is this on the right side you can see there is a person talking to a YouTube video. Then the data that being stored as a person name can be stored in the YouTube video with a relationship of produce, right? A person produced a YouTube video saying that also the person that is watching it can be audience name Mike. So this is a relationship that can be stored very easily on a graph, and knowledge graph will be able to traverse that query if the user is asking about the person that is watching the YouTube video might and very easily access this data very accurately by storing data in this manner. As you can see, this is the structure that we implement for this demo, and this is why we want to use a graph. The graph have certain method which we use. The first on the left side is the most difficult but the most useful one, which is the graph taxonomy is dictated by domain expert. The second in the middle is hybrid, where the domain expert actually use large language model, which I'm going to present today, to extract the knowledge from the graph. And the third one is a totally automated one, which is letting the large language model automate a certain understanding of certain problem and impose that on that graph. And the graph produced is totally automated and controlled by large language model, which is might have a problem with inconsistent graph structure due to the non-deterministic behavior of the large language model. So no matter what approach we use, after we construct this graph, we will have to populate the graph from DB by defining the desired node and relationship. Therefore, inconsistency can be eliminated. Right. So why knowledge graph? Well, the first thing to know is it's suitable for both structured and unstructured data. It's actually domain specific, very powerful for a certain particular knowledge worker like doctor, for example. And explainability and traceability is super. Allow user to ask questions that can be answered using multiple knowledge points within a single database, and even multiple database which has not accessible through normal vector store or rack system. So the user case must be a chatbot for unstructured medical report, which I'm going to demo today, and also maybe a chatbot for assessing complex relationship between database. But of course, there is con to this the con is always, it's not as generic as RAC, right? It's very specialized and it's require more technical knowledge about the doctor, for example, in the knowledge graph, or for knowledge worker in the clinic, right? And it's also kind of tedious and slow to implement properly, and it's not as mature as a RAC system out there. Of course, the most important always surpass the most. There's a disadvantage. The advantage is totally true. If you are talking about answering sophisticated question, knowledge graph is perfectly fitted for this kind of user case. And deciding what to know, when to use KG, or when to use a conventional RAC depend on your data characteristic and also your application specific need. Answer simple questions like direct inventories, like for retail, might not be justifiable. But if answering questions from patient and doctor that needed a lot of knowledge, in-depth knowledge, and not only in that it has to be accurate, then you're talking about getting KG involved in it, right? So we have to really be careful in how we consider the use of combination of both vector store or graph knowledge graph. Okay, so back to this this system that I'm trying to show in the demo. So as you can see, this is a demo. As a user is actually going to use the UI, which is written in Gradio, which is one of the UI, web UI, and the line in the green is actually the database. The CSV ingest, or the spreadsheet can be ingested in a graph database, and then after that, once the data is being structurally imported or ingested, then the graph agent is able to do on the orange line the query DB and the result. And the return query will then be passed to the user UI as shown here. And also at the blue line, you can see either you can use the large language model from OpenAI, or you can use your local, which I'm going to use local because I'm trying to demo this particular user case on a small device that I have been trying to push. As you can see here, this video shows my small little device here that's RAC that is actually storing all the user data, including all these patient data or whatever inventory data that is being ingested into the form factor of this particular size, which then talk to your microphone on the top left, top right corner. You can see.
How are you?
So,
all good? Yeah, good.
So let's go back to the demo.
All right. Was it good?
Here's the demo here. So you can see
at a desk, I don't know.
we have this particular demo running on my device, and you can see on the line 8 is actually ingesting the command, and one of the things that I'm using is actually the local model here. You see local host is 11434, which is
You're like, hey, it could happen.
local llama, and the API key is OLlama, and I'm using a model called Mixtral, which is a bit powerful. So this particular line 10 is this patient data. You can see the patient data is just a medical sheet of a 34-year-old presented a complaint on the fever and a chronic cough, and he was a smoker and has history of pulmonary tuberculosis, sorry about my spelling it, that has been treated and cured and all this. So from all this medical record, we actually extract using local llama to map it to certain relationship graph shown here, which the large language model was over. The taxonomy that we are trying to look for is a certain patient name, a case number assigned to it, and what kind of symptom the person is having, and the diagnostic, plus the biological background of the person, and also the disease, and also the body type. So you can see from here This is the prompt that we use for this particular taxonomy to establish ontology of the structure of the graph database. So from this case sheet, I can see a patient below. Extract the following entities relationship described in the mentioned format. First, the instruction to LLM very clear. Always finish with the output, which is like an API that I want to do it. This is like a function calling, and the function calling that is going to detect and also control the format in which the output extracted data will be in the form of the particular schema. So this schema is this. First, look for these entity types in text and generate a comma separated format. So we want a CSV file or whatever, and the CSV file should have this ID property of each entity must be aligned, and then label is case, person, symptom, disease, body system, and diagnosis, and biological. So you can see all these instructions is absolutely controlled by our large language model and detected by the person that is specifically like the doctor that is going to control the output for the structure of the graph, so that they can treat all the medical sheet as a certain portion of the format according to this schema. And you can see number 3 here. This next generate each relationship as a triplet of head, relationship, and tail. So we actually generate the relationship, and then actually has a case for person, and then person has symptom, or what symptom, the property, and then person has disease. Person has symptom plus where is the symptom on the chest, or maybe the disease affect the heart, or the person has diagnosis and diagnosis. So diagnosis is have shown biological, which part of the body is actually shown to have problem, right? So the output should look like this: entity, label, case, ID, string. So this is exactly the format that we're using it. So the output will then be fed into the cipher, which is Neo4J in this case. A cipher is a particular format of language, just like my SQL is. SQL is a language. Certainly the Neo4J graph knowledge database has a certain format, and that format is by the name of cipher. So once the entity is being extracted, as you can see here, it's actually going to be in the format that the Neo4j is able to use, and then from here 92 is actually converting the cipher into a particular database that is ingestible. And once the database is being ingested, you actually are completely the particular format you can see here is going to be stored here, and then we can start to do some query, as I'm going to share with you later on how we can do it. Let's run this and show you the demo. Here we'll be running this one. Well, I already can install it. All I have to do is to run this. Yes, it's done. So I'm going to run this one, cleansing. Run this one. It's cleaning the. This is actually pre-processing the input, and then take the medical sheet and extract the entity. Now that I finished this, I can do this. So I have declared the prompt now. I think this is good, this done. So this part is just the prompt template that I use. So this is the part where it's getting exciting, because this is the part where I actually do the pre-processing result after uploading to the Neo4j. So before I do the ingestion, I have to start the Neo4j database. Here is the one that I actually showed. This is using 5.24, running locally on my machine, and I can do connection here, which I already have the database right now. What I need to do is to just start the database. So now it's running the database. You can see it's active. So after I run the database, I should be able to start ingesting this. So let's do that. Now I'm going to start ingesting it. Here you can see. So here is the one that does some sort of a cipher constraint, which is all the case number that I extracted actually has to unify. So I'm doing that right now, and it's done. And you can see I can run this. This is the part where I actually do the cipher conversion, and then run here is just going to finish off this GDS run cipher. So this is the one that is going to do the processing. As you can see, we are actually doing the processing for all this particular file that I already have. So there is a lot of medical record that is exactly like this, but in different for different patient. There is total of 400 record, which will take some time for us to run it. I already run it, as you can see, running pipeline 191 file, and then reading it, extracting ENR. ENR talks about 122 seconds, generate cipher, ingesting entity, ingesting relationship, and processing is done. So this is all done, you can see. And then it will take some time for us to ingest it, and then the end of the day is about showing off the database. I can show you exactly what I'm talking about. You can see from the browser or the Bloom. So as you can see, there is a lot of cases, total of the cases. By clicking the node, you can actually see how many cases are there. Right now, I actually do 25 for the limit. Because of the sake of the diagram, it actually 25 displays 25 a case number. And you can see if you click in here and you zoom in a bit, I can show you what I was talking about. This particular case, you can see the relationship graph. It's a 69-year-old patient, and he's a female, and you can actually see what kind of the diagnostic it has, and so on and so on. So this is already done. So based on this particular graph, knowledge graph that we already established for the clinic, we can engage in question and answer by the chatbot. Let's start the chatbot right now. Let's just do some chatbot kickoff. Let's open a terminal here, and let's go to the Neo4J. This is a particular healthcare demo, Neo4J healthcare demo. And you can see this is the place where you can actually run the UI. You can go into the UI, and it's actually using Streamlit. You can go into Streamlit, and then you can actually run Streamlit. Run home.py. That's all you need to do. So this is a result. As you can see, there is all this statistic that you can run, and it's automatically generated by the UI. The UI can actually tabulate and different kind of statistic out of all of your knowledge graph. It generates a lot of statistics. But what we're interested in, chatbot that we build on top of it, and you can ask away questions like, for example, which patient has the most symptom? You can actually ask this kind of sophisticated questions. take some time to answer the question because it's using the local llama and it's not working on the OpenAI key. It's actually using the local server. So I can see this is the chatbot that is accessing the Neo4J knowledge graph after we ingested using my flow that is totally hybrid. When I say hybrid, I mean here I'm referring to this. Just go to this one again. This is my presentation. What I want to explain is this: we are using the hybrid model. Here in the center here, see this hybrid that is using the large language model knowledge to generate. Here GPT-4 is replaced by my Llama here, which is a Mistral, and you guide in constructing the graph. Then here, which is I want to just do some query, like for example I'm saying how many cases are there. It's running here. So there are 33 cases in total, which is what we want is actually trying to generate the natural language, converting it to cipher statement, like match case, return count as total case. Okay, we can ask something else like this: which patient has the most symptom? See how it goes. Which patient has the most number of symptoms? So this is not able to be found. Let me just find something else. Something like this. How many patients suffer from both cough and weight loss? See, actually the quota. Okay. So at least the disease called is multicular lesson affects 7 patients. Therefore, it is a disease that affects a significant number of your patients. Okay, so sometimes it doesn't really answer question because of the fact that you're actually using a local model here. I can only show you something. You can see actually using a very cheap model on local llama, which is the Mistral. See, I'm using a low llama Mistral, totally free, but sometimes we just generate this not able to answer question. But some of the sophisticated question like this is very nice, can be attacked by using knowledge graph. And actually the cipher promotion is pretty awesome. Like this, it's actually doing a match of disease, then has diagnostic, and then has return a name and the disease count of that affect the patient most by the number of most severe disease. Thank you. This is the end of the demo. I hope you can understand a bit more about this knowledge graph. Try to send email to me for answer questions. I mean, I can answer some question you have for this intelligent medical assistant that we are trying to build for the medical vertical. Thanks.